Hey, so today we're going to go over exponent properties. Okay, we're going to start with the basic exponent properties, and then we're going to work our way up into the more advanced or more complex properties. So what we're going to start with is we are going to start with the zero exponent properties. And this is on the bottom right-hand side of your foldable. So the zero exponent property says that a non-zero quantity raised to a zero exponent is equal to 1. So, and that's just telling us that anything raised to the zero power is going to equal 1. So x to the zero power equals 1, 6 to the zero power equals 1, anything to the zero power. We can say a number 225 raised to the zero power, and that will equal 1. It doesn't matter what the number is, anything raised to the zero power is going to equal 1. Okay, and the next property we're going to talk about is the power of a quotient property. So, and this says to find the power of a quotient, apply the exponent to the numerator and denominator. And this is telling us to distribute, so if we're given the expression x over y raised to the nth power, we're going to distribute that m to both the numerator and the denominator. So our simplified expression would be x to the nth power and y to the nth power. So if we replace these expressions and these variables with numbers, then we could have 4 to the second power and over 7, and put that in parentheses. We would have to take that 2 and distribute to the top and the bottom, because that 2 is outside the parentheses of both the 4 and the 7. So that would be 4 to the second power over 7 to the second power. And if we simplify that even more, 4 squared is 16 and 7 squared is 49. So that's just telling us to distribute whatever is on the outside to the top and the bottom, numerator and denominator. Okay, next we're going to talk about the negative exponent property. And with negative exponents, and this is on the left side of your foldable, these are non-zero bases raised to a negative exponent, and they're equal to the reciprocal of the base raised to a positive exponent. So this is saying that, say for instance, we have x to the negative nth power. Well, we can't have a negative exponent, so we have to put a 1 over that and then make it positive. So we have to make the x and we have to make the m positive. Okay, so that exponent changes to positive and the x stays the same. So say for instance we used a number like 3. 3 raised to the negative second power is just going to be 1. We keep the 3 and we change the exponent. Okay, we're going to change the exponent to a 2. So we have, basically we have 1/9. Now if we have a negative exponent and it's raised to both variables, now to make those positive, because we have to have positive exponents, we can't have a negative exponent, we would have to move the x to the bottom, because when we switch floors, meaning the x is on the first floor and the y is on the second floor, if we switch floors, that makes the exponent positive. So when we switch this, we'll switch this to the bottom. We have x to the nth power on the bottom now, because that makes a positive exponent when we move it. And then we're going to put y on top. But remember, we had to distribute that negative, so the negative goes to both. So when we put y on top, it was a negative m exponent, so now it's going to be positive. Okay, and then that's reduced. Okay, we do the same thing with numbers. So if we had 3/4 raised to the negative second power, we would be distributing that. So everything would be raised to this negative second power. So what we would have to do when it says reciprocal is just flipping the fraction. So instead of 3 over 4, we would have 4 over 3. And then those would both be positive. So we can put the little 2 exponent on the outside. And then we can distribute that. So 4 squared would be 16, and 3 squared would be 9. Next, we're going to talk about the identity exponent property. Okay, and this is a non-zero quantity raised to the first power is always equal to itself. So if we had something like, let's say, x to the first power, that's always just going to equal itself. So it's going to equal x. So if we had, say, 36 to the first power, that's going to equal itself, which is 36. Or say we had 4 to the first power, that's going to equal itself, which is 4. So an exponent of 1 is always going to equal itself. And keep in mind, the exponent of 0 equals 1, but the exponent of 1 equals itself. Okay, our next product of powers that we're going to talk about is our next exponent property. And the product of powers is basically to multiply powers with the same base and add the exponent. So anything that has the same base, and this is at the top right hand side of your foldable, anything with the same base, you can add the exponent. So if they have the same base, like x times x, those are the same bases. Okay, so if that one had a, let's say it had an exponent of m and an exponent of n, then what we would do is we would just take the top numbers and we would keep the base, which was x, and then we would add m plus n. And that would be our final answer. Well, if we have numbers like 2 to the third power times 2 to the second power, we're going to do the same thing. We are going to keep that base, which is 2, so 2, and we're going to add these exponents. And our next exponent property is power of a power property. And if you open your foldable, that's right underneath. And it says to raise one power to another, multiply the exponents. So that is when a power is raised to another power. So if we have x to the nth power, and the m is inside the parentheses, and then we have another exponent outside the parentheses, we are just going to multiply the exponents. So we'd multiply these two together. So we would have x and then m times n. So we're going to multiply those two together. Now if those were numbers, then we would come up with a more simplified expression as our answer. Like for instance, if we use 7 to the third power raised to the second power. Okay, we would keep that base of 7 and then we'd multiply 3 times 2. Well, 3 times 2 is going to give us 6. So our simplified expression would be 7 to the 6th power. Say we had something like 2x squared raised to the second power. Well, if we have something like that and it has more variables and you have a constant in here as well, you're going to distribute that too. So you'd have 2 to the second power, which 2 to the second power would be 4. And then x, we would multiply these together and you'd have x to the 4th power. So it'd be 4x to the 4th power. So all of these are pretty simple. It's just the steps that you have to remember. Like the little steps of when to multiply and when you simplify and when you distribute. Okay, last but not least, we have the quotient of powers property. So this is on the top left-hand corner of your foldable. And if you open it up, it says to divide powers with the same base, subtract the exponents. And this is actually my favorite rule. And we're going to use this a lot. So it's basically saying if we have like say we have a quotient like x to the nth power and x to the nth power, we're just going to take those and we're going to keep the base, which your base is x, and we're going to subtract m minus n. Okay, and that's what it looks like just as the rule. If we actually use real numbers, like 5 to the 4th power over 5 to the 2nd power, we would do the same process. We would keep this base of 5, but then we would take the exponents and we would do 4 minus 2. So we're going to subtract. Anytime you see a division sign, you're going to subtract that exponent. So we're going to do 5 to the 2nd power, which we all know that 5 to the 2nd power is 25. Okay, and then the power of a product property. So we're going to find the power of a product property. It's a little hard to say. To find the power of a product, apply the exponent to each term. Okay, so if we have, let's say we have two variables like x, y, and we're going to raise that to the nth power. That means that we're just going to distribute that m to each variable, because those are different. That's an x and that's a y, so those are different. But we're going to apply that m to both parts. So x to the nth power and y to the nth power. So if we're using numbers like, let's say 5 times 6, okay, we want to raise that to the 3rd power. We're going to distribute that 3 to the 5 and to the 6. So we have 5 to the 3rd power times 6 to the 3rd power. Okay, and going back, I did that example with the power of a power property when I distributed that 2 to the 2 and to the x. Okay, so that's just distributing. Okay, so this is an overview of all of the exponent properties that we're going to cover, and I hope that you use this to study. So those are our exponent properties.